In describing the motion of an object, you can use quantities such as speed and velocity to quantitatively describe how an object is moving. For instance, you can say that an object is moving slow or that it is moving fast. However, describing motion in such a manner is not enough. You need to quantify how fast is fast and how slow is slow. As such, you have to express speed and velocity numerically. How do you quantitatively define speed and velocity? In this video, you will learn about speed and velocity. At the end of this video, you should be able to describe the motion of an object in terms of distance or displacement, speed or velocity, and acceleration. The speed is defined as how fast an object changes position. It is known to be a scalar quantity since it is fully described by a magnitude only. On the other hand, velocity is how fast an object changes position in a given direction, and noted as vector quantity, which is presented with magnitude and direction as well. In this illustration, although they have similar magnitude, however, you can still see the difference between speed and velocity by looking at how the motion was described. To fully understand the difference between speed and velocity, let us use this figure. In the figure, we can see that the boy traveled from point A to point B and point B to point C with a speed of 3 meters per second. While going back to point A from point C, he has a speed of 5 meters per second. What is the boy's speed when he traveled point A to point B? 3 meters per second. How about his velocity when he traveled the same distance? 3 meters per second northeast. Now, let us learn how to quantitatively describe speed and velocity. The formula used to solve for the speed and velocity are just the same, but they differ in terms of distance and displacement. The formula to solve for the speed of an object is S is equal to d over t, where S is the speed, d is the distance that the object traveled, and t is the time. However, in velocity, we use v to represent the velocity. Also, instead of distance, displacement, which is a vector, is represented by a symbol d but with an arrow above it. Let us answer this sample problem. A cyclist can travel a distance of 120 kilometers in 8 hours. What is the average speed of the cyclist? To solve this problem, always follow the Gresham format. First step is to look for the given. Given are 120 km, which is the distance, and 8 hours, which is the time. The required quantity to look for or solve in the problem is the average speed. Equation. Write the working formula, which is speed is equal to distance over time. Solution. Substitute the variables in the formula with the given values in the problem. Simply divide 120 km by 8 hours and you will get an answer of 15 and copy the unit. So, the speed of the cyclist is 15 km per hour. If we are looking for the velocity of the cyclist, since direction is not indicated in the problem, you can just put an arrow above the symbol of velocity to make it identifiable. In some cases, if the missing value is not the speed or velocity, we need to derive the working formula to make it appropriate in solving the problem. Let us solve this problem and analyze what is the missing value. How far can a bus travel in 4.5 hours if it travels along a straight highway at a speed of 40 kilometers per hour? Let us identify first what are the given values. So, the given are 4.5 hours, which is the time, and 40 km per hour, which is the speed of the bus. The missing value in the problem is the distance. Equation. Since the general formula is not yet applicable in solving the problem, we need to derive the working formula. We need to multiply both sides by time and cancel it as the denominator of distance. Place the time at the left beside the speed to show the multiplication. So, The formula to get the distance that the bus covered is speed times time. Solution: substitute the variables in the formula with the given values in the problem. Show the cancellation of units and simply multiply 4.5 to 40 kilometers. The answer is 180 kilometers. So, the distance covered by the bus after traveling for 4.5 hours with a speed of 40 kilometers per second is 180 kilometers. If displacement, it is still 180 kilometers, but it is denoted by D with an arrow symbol above it. Let us solve and analyze this another problem. A person can walk at a speed of 2.5 kilometers per hour. How long in minutes will it take for the person to travel 6 kilometers? Using the format, the given are 2.5 kilometers per hour, which is the speed, and 6 kilometers, which is the distance. Required: we are asked to look for the time in minutes. Equation: since the two previous formula we use are not suitable to this problem, we need to derive the working formula again. Again, from the standard formula, multiply both sides by time to cancel the time below the distance. Then the equation will become distance equal to time times speed. In this case, we need to divide both sides by speed to cancel the speed beside time. So, the formula now is time is equal to distance over speed. Use this derived formula to solve for the missing value. Solution: substitute the given to the formula. Cancel the kilometer and simply divide 6 by 2.5 hours. So the answer is 2.4 hours. Since we are asked to make the time in minutes, we need to multiply 2.4 hours to 60 minutes because 1 hour is equivalent to 60 minutes. So, the final answer is 144 minutes. I hope this video lesson has helped you to understand the differences and similarities between speed and velocity. Also, the process on how to solve for the speed or velocity of an object and how to derive formulas based on what is missing in the problem. Don't forget to subscribe to my YouTube channel for you to be updated on my latest upload of a video lesson. Thank you for listening and have a day full of blast.